Let's discuss about photoelectric effect. So what is photoelectric effect? Photoelectric effect is actually the process where the light incident on the metal, the electron will be ejected from the metal. The ejected electron is often called photoelectron. So where the term electric come from? The term electric come from the movement of electron, which is the movement of charge. In theory of electromagnetism, we already learned that when the charge move, the current will be produced. So that is where the term electric come from. Now I want to explain how classical theory failed to explain the photoelectric effect. Okay, classical theory said that the ejection of electron is highly depend on the intensity of light, not the frequency of light. However, when they do the experiment, the result is the other way around, which is the ejection of electron is highly on the frequency of the light, not on the intensity. Which means, whatever the intensity of light, the electron will still ejected if it has enough frequency. Classical theory also said that when light incident on the metal, it will require some time for electron to absorb the energy. It's about a few seconds, and then the electron will be ejected. However, in the experiment, when light incident on the metal, the electron will ejected immediately without require some time to absorb the energy. So in 1905, Einstein are able to explain the photoelectric effect. Einstein assumed that the light is like a particle, light behave like a particle. Before this, we already know that the light behaves like a wave, but Einstein says that light also can behave like a particle that we call photon. Okay, Einstein actually take the idea from Planck, which is the quantization of energy, but he applied it on light. He said that photon, or the particle of light, has quantized energy, and each photon will have energy hf. As you can see here, each photon will have energy hf. Einstein also said that electron will absorb energy in a quanta, which means one photon only can be absorbed by one electron. There is no possibility for one photon to be absorbed by two electrons. Also, there is impossible for two photons absorbed by one electron. So, the key thing here is one photon is for one electron. The energy of photon incident of the metal must exceed some required value, which is we call work function. So if the energy is less than work function, what happens? The electron will not be emitted. Okay, if energy of the photon equal to the work function, the electron will be taken out from the metal. However, it will not move. If the energy of photon greater than work function, the electron will be taken out from the metal, and then it will move with some velocity. So that's mean, in this case, the energy of the photon will be used first to take out the electron from the metal. The extra energy will be converted to the kinetic energy of the electron and make them move with some velocity. The work function is different for different metal. Let's say we have two metal, metal A and metal B. The work function for metal A is not equal to the work function of metal B, which means different metal require different amount of energy to take out the electron from it. Let's now we apply the conservation of energy in photoelectric effect. Okay, we already see this kind of diagram. This is the photon with energy hf hit the metal, and then the electron will ejected with some kinetic energy. If we apply the conservation of energy, we will get this kind of equation, which is the energy of light is used to take out the electron from the metal, and the extra energy will be converted to the kinetic energy of electron, which is allow electron to move with some velocity. If we rearrange this equation, we will get this kind of equation. This equation actually has the form of linear function. Okay, so if we illustrate this equation in terms of graph, we can get the linear graph. Okay, in mathematics, we already learned that the linear function has form of y equal to mx plus c, where y and x is the axis, y and x axis, m is the slope of the graph, and c is the y-intercept. So for this case, y-axis should be the kinetic energy, x-axis is the frequency, the slope of the graph is h, which is Planck constant, and the y-intercept is negative v. So there is some important quantity in this graph actually, which is the intersection between the linear graph and the x-axis. This value is what we call cutoff frequency. Cutoff frequency is minimum frequency needed to take out the electron from the metal. So light that incident into the metal must have frequency greater than cutoff frequency so that electron can be taken out from the metal. We already see this kind of equation, which is the general equation of photon. Okay, if we want to replace E by work function, which is phi, okay, if you want to replace E with phi, where phi is the minimum energy to take out the electron, we must have the frequency that is needed to take out the electron, which is now we know as cutoff frequency. So if we want to replace E with phi, we must also replace F with Fc, which is cutoff frequency, so that we come out with this equation. Now, let's see this kind of situation. So this is like an analogy that we will use after this. Okay, so understand this first. This, let's say this is a gun. The gun that will shoot a white ball. Okay, and from this gun, we can adjust the energy of the white ball. Let's say for case 1, we adjust the energy of white ball to be E1. For the case 2, we adjust the energy of white ball to be E2. And for the case 3, we adjust it to be E3. Okay, so there is also the black ball incoming from the other side. Okay, this is black ball incoming from the other side with the unknown energy. We don't know what is the energy of the black ball. Okay, so in the right side is actually what happened next when two balls hit together. Okay, so our task is to determine what is the energy of the black ball. Okay, let's look for the case 1. We set the energy of white ball to be E1. We shoot the black ball, and when they hit, what happened? Both of the ball move to the right. Okay, for this case, is it the energy of white ball equal to the energy of black ball? No. For this case, there is no. Because for this case, the energy of white ball is greater than energy of black ball, since it are able to push black ball to the right. For the case 2, we set the energy of white ball to be E2. Okay, and we should, when they hit together, both ball move to the left. That means this is also E2 is also not equal to E. Okay, but for this case, E2 is less than E because the black ball are able to push white ball to the left. Okay, if you look the case 3, we adjust the energy of white ball to be equal to E3. When they hit together, both balls are stopped moving. Okay, for this case, we can say that E3 is equal to E because both of them has the same energy, and as a result, both balls will stop. So what we can say in this situation, we can say that to get the energy of the black ball, we need to stop the black ball by using the white ball. Okay, so remember this situation, we will use it to discuss about this. Okay, this is actually when we apply the photoelectric effect in the circuit. Okay, let's first explain what is this circuit. This is a metal that is called emitter. Okay, this metal will be accept photon and then eject the electron. This is also a metal that we call acceptor. Acceptor will receive the electron from the emitter and allow the electron to move inside the circuit. Okay, and we have the battery, which is we can change the battery with the different voltage, so we can say the voltage of the battery are variable. Okay, And also we have the galvanometer. The galvanometer are used to detect the direction of current. If the needle of galvanometer deflect up, that means there is current flowing upward. If the needle of the galvanometer deflect down, that means there is current moving downward. Okay, so the battery will flow some electron. Okay, will produce electron and move in this direction. Okay, with the energy E back that has a value EV, where E is the charge of electron and V is the voltage applied. Okay, so now how we want to determine, okay, for this case, how we want to determine the kinetic energy of this electron, which is we call photoelectron, due to the photoelectric effect. How we want to find its kinetic energy. So if we use the situation like this, to define the kinetic energy, to calculate, to measure the kinetic energy, we need to stop this electron. Okay, how to stop it? By using this electron. Okay, so we can consider this, the battery, as the gun, this electron as the white ball, and this electron as a black ball. So if we are able to stop this electron, which means the energy we supply to this electron is equal to the kinetic energy of this electron. Okay, so actually we already answered this question. How to determine the kinetic energy of photoelectron is by stopping it using electron from voltage source, which is the battery. Okay, so the question arises, how to know whether the photoelectron stop or not? Okay, so how to know that? We must observe the galvanometer. Okay, the galvanometer, when there is no deflection on the needle, that means there is no current flowing into the circuit. Okay, so if this electron have the same energy with this electron, when they hit together, they will stop at some point. That means there will be no current flowing into the circuit. So to know that, to know this electron, whether this electron stop or not, we need to make sure that the needle of galvanometer not deflect up or down. Okay, observe the galvanometer, make sure there is no deflection. Okay, if we look at this diagram, when there is no deflection, that means the energy of the electron from the battery is equal to the kinetic energy of photoelectron. If it deflect up, which means the energy of electron from the battery is greater than kinetic energy of the photoelectron. If the needle is deflect down, the energy of electron from the battery is less than the kinetic energy of photoelectron. So we must make sure that there is no deflection on the galvanometer needle. So from this, actually we can conclude that kinetic energy of photoelectron is equal to energy of electron from battery that are able to stop the photoelectron. So the energy supplied by the battery, if the electron are able to stop the photoelectron, this energy will equal to the kinetic energy of the photoelectron, where we call it EVS. The subscript S is actually stands for stop. Okay, so Vs is called the stopping potential, which is the potential, the voltage of the battery that are able to stop the photoelectron. Okay, so we can complete this equation, which is the kinetic energy of photoelectron is equal to the energy of electron from the battery that are able to stop the photoelectron, and also equal to HF minus V, like what we are discussed just now. Okay, that's all from me. Thank you for watching. Bye bye.